So when we talk about ratio proportions, we're really talking about the proportional relationship. So we have the equivalent fraction relationship of A over B is equal to C over D. And there's a proportion involved that's going left and right, but also up and down. Okay, so this is important to relate it to that. Now, there are some other strategies, and we're going to start using these other strategies because we need to be a bit more efficient and not always have to rely on this. However, if we're ever stuck, we always go back to our proportional relationship. So here we have a unit ratio. We're being asked for a unit ratio. So this unit ratio, to find the unit ratio, we divide. So we can do 5 kilometers divided by 2 centimeters, and we get 2.5 kilometers per centimeter as a unit rate. We could also do it the other way around. We can say 2 divided by 5 kilometers, and as long as we keep track of the direction or our units, we can use 0.4 centimeters per kilometer. Now, again, we can set up this proportional equation to solve these problems. Okay, so we can just say that, our map distance of 6.3 centimeters compares to some x. And we know that our map distance, we can use either proportion. So I'm going to use 0.4 centimeters to 1 kilometer and use our proportional equation. So that's one way to do it. Now, we really want to start developing a more efficient way to do this, and this is called rate or unit analysis. So if I want to convert 6.3 centimeters into kilometers, what I can do is use this property that times on top, divide on bottom. And if I want to get rid of the centimeters, I need to use this proportion and put the centimeters on bottom. Now it doesn't really matter which one I use. I can use the 2.5 for 1 centimeter or 0.4 centimeters for 1 kilometer. So I'm going to use the 2.5 kilometers for 1 centimeter. And what ends up happening is, because this is a divide unit, and that's a times unit, they cancel out, and we end up with kilometers as our final units. And all we have to do is keep track of times on top, divide on bottom. So we have times 6.3 times 2.5, and we end up with 15.75 kilometers. That would be the same as here. Okay? In this case, we would end up going in the opposite direction. We would end up dividing by 0.4, but we get the exact same solution, okay, using either one of these unit rates. In fact, we don't even have to use the unit rate. We could have even used this rate here. As long as we kept track of times numbers on top, divide numbers on bottom, you'll get the exact same solution. So here I'm going to start with 47 kilometers, and I'm going to use my multiplying strategy. So I want to know the map distance. I need to get rid of the kilometers distance with kilometers on bottom. So I'm going to use original scale here. And again, it doesn't matter if I use my unit rate here, my unit rate here, or my original scale there. Okay. As long as I keep track of my units, kilometers on top, kilometers on bottom cancel out, I'm going to be left with centimeters units. Okay, and I know that I've done it correctly by keeping track of my units. So here, times on top, divide on bottom, I do 47 times 2, divided by 5. Remember that this is 47 doesn't times on the bottom. This is a time, so it just stays on the top. Okay, so 47 times 2 divided by 5. We end up with 18.8 centimeters of map distance. Okay, so we're going to use the same strategy down here to convert grams to ounces. We're just going to use this rate, and we can use the unit rate if you like, or you can use that whole number rate. It doesn't really matter. I'm just going to use, the unit rate happens to be, I think, about 28.3 grams per ounce or something like that. Okay, but we could find the unit rate very easily by dividing. Okay, but I'm not going to use the unit rate. I'm just going to use my rate analysis. So I'm going to use grams. To be able to convert this to ounces, I need to get rid of the grams. That means that I have to divide by whatever the grams units I'm using. And I'm going to put the ounces on top. I can see by my unit analysis, my answer is going to be in ounces. That's what I'm looking for. And I just times on top, divide on bottom. So 305 times 16 divided by 454. And we get approximately 10.75 ounces. And then we can do the same thing from ounces to grams. We start with our ounces. Okay. I'm going to use my ratio here. I know that I have to put the ounces on the bottom to make sure that they cancel. I put the 454 grams on top. My rate analysis tells me that I have in the right orientation. And again, it's just times on top, divide on bottom. So 220 times 454 divided by 16, and I end up with 6,242. Let me just write that 6,242.5 grams. Okay, and this is my using this times on top, divide on bottom, my rate analysis. I'm basically using this idea that these units cancel out. I'm left with the units on top. Now, if you want to know how that relates to our proportional equation, okay, proportional equation in this last problem here looks like this. 220 ounces compares to X grams, and we can use 454, it's going to be 16 ounces to 454 grams. If I want to find my multiplier, I just divide. So 454 divided by 16, that gives me 28.3, let's go 28.375, okay? And notice that that's my multiplier going from here to here, times by 28.375. That's the same multiplier that I get here. Notice that there's my unit rate, 454 divided by 16. And basically that this proportional calculation, the calculation of proportional equation, is showing up in a linear form in this rate analysis. And the rate analysis is a much more efficient way of doing things.